Hi and welcome back to Module 8, the last one, and we are looking today at chemical environments. We touched on this in the last video that we were watching on how each hydrogen or carbon can have a different unique environment depending on those around it. So let's have a look at that a little bit further. What is a chemical environment? So we're looking at information about the number and the type of hydrogens and also the number and type of carbon nuclei that we have in the compound that we might be studying. And so if they are in the same environment, they will absorb the same amount of energy and therefore produce just a single peak. Now, what is a chemical environment? So our chemical environment looks at the atoms that we have and the electrons that might surround it. So it can be said to have the same chemical environment if it's attached in the same way to the atoms. Let's have a look at a couple of examples here. So if we're looking here, we've got ethane. So in this case, we've got one carbon environment and one hydrogen environment. So if you look at the 6 hydrogen atoms that we have here, we look at the 3 on the left. They are all attached to one carbon that is attached to another carbon via that single bond. And if we look at the ones over here on the right, we too have 3 hydrogens attached to one carbon that is attached to another carbon there. So each CH group here is identical, and because it is identical, it will only produce a single signal. Another thing we can look at here is mirror plane symmetry, and if we look down here and were to look down that bond, what is on this side is the same as on this side, and therefore also looking at that single peak on the spectrum. Now, if we look at the carbons here, the 2 carbon atoms that we also have are also in the same environment. So if we were to look here, this carbon is attached to another carbon with 3 hydrogens around. This carbon is attached to this carbon with 3 hydrogens around. And so that carbon will also produce a single peak. So in this case, we would expect to see 2 peaks, 1 carbon peak there and on the carbon NMR. And if I was looking at the hydrogen NMR, I would also see 1 peak because the hydrogens are in the same environment. But of course, we have carbon NMR and we have proton NMR, so they would not be on the same spectrum. They would be on their individual spectrums. So let's look at another one. Here, how many different chemical environments have we got? So here now we're looking at propane. Again, here I have these 3 hydrogens are attached to this carbon that is attached to a CH2 group. These CH3 group is attached to a CH2 group. So these 2 CH3 groups there are in a unique chemical environment. They are sharing the same environment around them. These hydrogens here are different. They're a CH2 for a start, so it's a different group there. And we've got this CH2 attached to a CH3 and again a CH3 on this side. So these 2 hydrogens that we have here are in the same environment, but they are different to the environment that these hydrogens are in. And so in this case, I've got 2 hydrogen environments, and I would see on a hydrogen or proton NMR 2 peaks. Now again, just looking at symmetry again, if I was to model this up with our MollyMod kit and I was to again divide down the center, I would have chemical symmetry across each side there, meaning these 2 are the same, and across through here, these 2 would be the same. Now, how many carbon environments have I got? Well, we have got here, this carbon is attached to a CH2, this carbon is attached to a CH2, so they're the same carbon environments. But this carbon here is attached to a CH3, and this carbon here is attached to a CH3, which gives a different chemical environment. So let's throw you out another one. Here we've got butanone. So having a look, pause the video if you wish and see if you can try and work it out yourself. So looking here, we have here again a CH3 environment. Again here we've got a CH3 environment, but these ones are different because of what they're attached to. So if I look here at these hydrogens, 1, 2, 3, these hydrogens are attached to a carbon, but we're fairly close here to a carbon that has got a carbon, like the carbonyl group here. Whereas these hydrogens, well, yes, they're a CH3, these hydrogens are attached to a CH2 group, which is further away from that carbonyl group, which will then affect that chemical environment there. So they're not equivalent. They will be two different hydrogen chemical environments. Now, if we look at these hydrogens here, this hydrogen here and this hydrogen here, they're the same chemical environment. So these two won't produce different peaks. These two are the same hydrogens, but this one is next to a CH3 bond here. This one is next to a carbonyl group. So again, it's different to these hydrogens and it's different to these hydrogens. So we're going to see 3 hydrogen environments here. Now let's have a look at the carbons. If I was looking at a carbon NMR, this carbon here is attached to a carbonyl group as well as the hydrogens. That's one environment. If I have a look here, this carbon is attached to a CH3 group and a carbonyl group. So it's different to this group and to this group here. If I look at this C here, it is attached to the C3 hydrogens, similar to the other side, but instead it's attached to a CH2 group. So it will give a different environment again. And then I have got this carbonyl group here. It's attached to a CH2 on this side and a CH3 on this side. So we have lots of different chemical environments there. And on that carbon NMR, I would see 4 separate peaks. So we'll practice a few of these in class. See you then.